2, and 3. All right.
Okay. This will be 15 minutes, and today Parham, which is right in front of us, the data engineering expert, is going to be talking about Docker and how it's in relation to data engineering and why you need to know it. And it's, I guess, is this a hands-on one?
That's all hands-on today. So I'm going to go completely through Docker CLI and building Docker images, hopefully in 15 minutes. We'll see.
Nice. Okay, well, why don't you give us a tiny bit of your background, because I know it's extensive, and if anybody would like to know more about Parham, he is on LinkedIn. So yeah, give us a little bit of your background first.
I'm Par from DataStack.Academy, or Parham. I'm one of the people who, I founded DataStack.Academy, but also one of the content creators, also the mentor for our bootcamp. And I've been a data engineer, or I've been around data pretty much for almost 20 years. It's been a long time. I know data, and that's all I know. Yeah, today I wanna show you guys Docker and Docker CLI in a 15-minute pretty much demo, and show you guys how to use Docker CLI and how to build Docker images. Docker is a very prominent tool now. It's used by data engineers, it's used by front-end, back-end developers, and it's used pretty much by developers everywhere. It's a great tool for shipping code and software and packing, everything you need in these containers, and then shipping those containers to different environments and having them consistently run in different environments. So the problem with development used to be that, you develop code on your machine, you install a lot of libraries, a lot of packages, you have a lot of configuration, but that really wouldn't be transferable to other environments because you did all that work. With Docker, it takes that problem away. So you start from these very base images or Docker images, and then you pack your code and you pack all the configuration there, and that's very shippable to different environments. You can push that to what's called Docker Hub, which is a central repository where all these Docker images are, and then anybody, your friend or anybody publicly, can pull that and run that on their environment, and it runs consistently the same on their environment without you having to do anything, or without them having to go through a big setup guide. It's also highly used by the backbone of all the cloud serverless technology. So it's a great way to, these containers can run on the cloud and can run very easily, again, same way as they run on your machine. And the nice thing is that the cloud only charges you for the amount of time, or the execution time, that those containers run. So you don't have to stand up like a dedicated server and be charged the entire time that dedicated server is up. You only pay for just the execution that you use. So with that said, I'm gonna dive right into it. It's pretty easy to get Docker. You can just go on Docker website and click the install Docker, or just Google search install Docker, and you come to this page, and you can install Docker on any of the platform that you have. Once you do that, the next step is usually the Docker Hub. Docker Hub, like I said, is where all these images people have developed, and there's thousands and millions of images there, and people have loaded these images here. And you can search for any image that you want. We're going to start by this busy box, which is just a very simple Linux image. It's a very small and simple Linux image. Usually on the Docker Hub, there's a documentation for that image that you can follow how to use that image. So there's some documentation here for different images, like if you download a database, you can go how to use that database, etc. So we come here, and this is our Docker command line. So once you start Docker, you get the Docker command line. You get this command. And what I'm going to do, the very first thing that you would do, you will pull an image from the Docker Hub that you want to use. So the syntax here is Docker. After Docker is the command within Docker that you want to execute. And for the Docker pull, the next thing is just the image name that you want to download. So we say Docker pull, BusyBox, and that's downloading the BusyBox image from the repository. And if I do now Docker images, which shows the images that I have locally on my machine, you can see that BusyBox is added. And you saw that how fast that was. So the next step is the main Docker command that I'm going to show you guys, which is the Docker run. So we say Docker run. So what we want to do is now running a container of this image. A container is like a running instance of the image that we downloaded. So Docker run is the same syntax. You say Docker run the command that you want to execute. And after Docker run is the image name. Usually there's options here, which we're going to get into. But in this case, we say the image name. You can also include the tag for this image. So the tag is like the different version, and you can see we downloaded the latest version, and the syntax just colon the tag name. And after that is the command that you want to execute inside that container. So right now we did the Docker run. We know which image we want to run, and now what we want to do inside that container. And we just do like a simple echo command. So we do hello from Docker for now. And you see that that was executed. So what we did, we ran a container of the BusyBox image, and we executed an echo command from inside that container, and that outputted to our command line. So one of the things to show you here is Docker PS is another command. So Docker PS lists the current running containers in our environment. And if we do that, we see that there's no container that's running now. When we ran this container ran and immediately exited because it just did an echo and it exited out. If we do a Docker PS -a, which shows lists all the commands, we see that there is an exited container, which we just ran a few seconds ago. So you see the BusyBox container was ran with the echo hello world, and that exited about 46 seconds ago. Now, one of the nice commands here is Docker system prune, which kind of gets rid of these lingering images. So this image has exited, executed, but it still kind of exists within our environment. And you can do this Docker system prune -f to get rid of any of those lingering images. Now, if I do Docker PS -a, you see that there's nothing there. So we cleaned everything up. Now, let's get a little bit more into the Docker run commands. So I'm going to show you how to pass different parameters to Docker run to make it run a little differently. So we're going to use the BusyBox image. This one, we're going to include a parameter that's -i -t or -it. And this one says that we want to run an interactive terminal when we run this container. And we're also going to name this container. We're going to say, or this one's name is container1, or maybe we'll name it BusyBox1. And we're also going to say --remove, which tells the Docker run to remove that container when the container exits, so it doesn't let it linger anymore. And now I'm just going to, again, say the BusyBox. I'm going to say the name of the container that I want to run. And now I'm not going to give it any, I could not give it any command, or I could give it that I want to run a shell. So this is just bin shell, so it opens a shell. So in this case, we're going to open a shell inside that container, and we're going to have an interactive terminal for it. So you saw that now we're just inside. So now we're inside that container, and we have an interactive terminal that we can use. So if I do ls, you can see I'm inside that container. Again, I can do an echo hello. And now when I exit from inside that container, I'm back into my host environment. And if I do a Docker PSA, you see there's no containers here because we told it to remove itself once we're done executing. So this is actually kind of very nice. So Docker containers are meant to be transient. So they meant to just exist for the time that they run. And once they exit, they completely kind of vanish from your environment. Now, one of the problem with that is, what if you actually wanted to persist some data between different Docker runs? And Docker provides a nice feature, which is called Docker volumes for that. And I'm gonna show you how to use Docker volumes. So Docker volumes is a way to persist data between your Docker runs, between your containers, and you can pass that data between containers. So we're going to use the Docker run command again, and we're going to do the same thing. We're going to do the -IT to get an interactive terminal. We're going to tell it to remove itself once it's executed, but we're going to use another command, which is the -V for attaching a volume to our container. So we're going to name this volume data and colon, and then the path that we inside the Docker container that we're going to mount this volume to. So this tells Docker to create a volume named data and then mount it to /data inside our container. And again, we're going to do just a busy box with the latest tag, and we're going to hit enter. So we're inside that container now. And if I do an ls of the root directory, you see there's a data directory. If I go to that data directory, it should be empty, or, oh, I had done this before. Sorry. So there is a file there. I'm going to remove that, but I'm going to echo something to that volume. So we're going to say echo, we do a message here. Hello from inside of Docker, Docker container, and have that go to test file. All right. So if I list test file now, it's there. I can list the contents of it. So here's test file. Now I'm going to exit out of this container. I'm going to do Docker PS to show you that container was removed. And I'm going to run this again, this command. So I can run the Docker run command again and mount the same data volume to the data directory. So now if I ls my data, you see that the test file is still there. So that persisted between the two Docker runs that I have, and I can more the content of data test file, and you see it's there. Another way to do this is to use the Docker volume ls command. So this is Docker. We want to run the volume command within Docker, and we got to list our existing volumes, and you see that the data volume is there. We can also do Docker to get a little bit more info about this volume, Docker volume inspect, and then the name of the volume. So now inspect the data volume, and it tells you when it was created, where it was mounted to before. And this is actually where the content of that volume on my host machine exists. So I can even do, I can list the content of that volume. And you see the test file exists there inside the actual directory on my host machine where that volume data is. Now this is nice. So the volumes are managed by Docker, but you can also attach a local directory as a volume to your Docker container. And you do that again by the -v command, but it's a little bit different. So what I have here is I actually have a data directory in this directory that I'm in right now. And let's list our data directory. You see there's two files there. There's a names and there's an indexed file. So what if I wanted to attach this directory to my Docker container? So inside my container, I can access local files. Very easy, or local files under my directory, and I can manipulate those. So again, we're going to do the Docker run. I'm going to again have an interactive terminal. I'm again going to run with the -- remove to remove itself after it's executed. But this time, when we use the volume command, instead of just giving the volume name, we're going to give a full path to our data directory. So I'm going to do the $PWD, which is the current working directory. And I'm going to say the data directory within here, and again, mount that to data. Because this is a full path, Docker realizes that, and instead of attaching that or creating and attaching that volume, it actually attaches the directory to our container. So again, I'm going to do busybox and do the latest version of that. And when I run this, I get a terminal. But now if you go inside our data directory, you see that we have the files that are inside our local directory, and we can work with them. And we can like echo DataStack, for example, to our names.txt. So we added something to the end of it. Let's exit the container. And if I go into my local data directory and more names, you see that DataStack was added to the end of that file. So it's an easy way to access local files within a Docker container. Now, another way that Docker is used, or very often is used, that Docker is used to host APIs or host applications that use ports. And I'm going to show you how to map a port to a Docker container now. So for this one, we're going to use another image, which is the ng-inx, which is a server. So we pull this image from the Docker Hub again. And again, if I list the data directory here, you see that there's also an index.html file. So I'm going to host this file as a web page or as a web server through the ng-inx web server. So I'm going to go back up a directory. I'm going to do the Docker run again. And this time I'm going to use another Docker run parameter, which is -d, which tells Docker run to run this container in detached mode. So to run it in the background. And that stops it from exiting pretty much like right away after we're done with it. I'm going to name this one, and I'm going to call it like server number 1. Again, I'm going to attach the volume, attach my local data directory as a volume to where ng-inx server serves HTML files. So that path is this. So ng-inx server, so inside the container, the ng-inx server looks at this directory and serves any HTML files from that directory as a web server. This is another syntax. So you can add another colon and do the permissions of that directory when you attach it. So this is, we say that this is read-only inside that container, this directory. So nobody can actually write from inside that container. Nobody can write to that directory. And now I'm going to use another option that's -p to map a port to my host. So the first is where I want to map this to. So, and the second is the port inside the container that I want to map. So this says that I map the port 80 of my container, which is where ng-inx server hosts the web page, to port 8080 of my computer. So we're going to say ng-inx. So at the end, it's just the name of my container. And I'm going to run this. If I do the Docker PS now, you can see that that is running in the background mode. And now I can go on a local, I can go to my browser, I can do localhost 8080. And you can see that that's the HTML page that we had, and that's being served. All right, so with this, hopefully you, let me show you one last command, which is docker remove. So to remove this image from running, we can do docker remove minus VF kind of forces the Docker to be removed immediately. The minus V says to remove any volumes if they're there. And now I'm gonna use the name of this one, which is server one. And that removed that container, so it's no longer running on my machine. So with that, you've seen sort of basis of the Docker CLI commands, and you can pool images, you can run them in different variations, run them with volumes, run them with attached ports. Now, really quickly, let me show you how to build these containers. So if I open my current folder, I have a directory here called image, and Docker containers are built from something that's called Docker volume or Docker file. This is a file that instructs Docker how to build an image. Usually they start from a base image. So in this one, we start from a Python image, and then they add files to that image, or they add instructions, they add software, and at the very end, they usually have a command, which is the default thing that you want to run when this container is executed. So in this case, we're building an image from a Python image. We're going to go to the home directory of that image and set that as our working directory. We're going to copy some local files into that directory. So we're going to copy the main.py, which is just a Python script that I have, and a data file, which is a list of names. And the Python file just simply prints the content of that data file to this screen. We're going to add those to this image under home. And at the very end, we're going to run the Python script in this container. So we're going to execute a command that says Python run the main.py. So very simple, and this shows you guys how you can use Dockerfile to build your own images. Now, to do this, we use a Docker build command. So first, I'm going to go to that image directory. I'm going to show you guys the content of this directory. And with Docker build, we're going to say Docker build to build the image, and we're going to tag this image. So the tag is like just the name that we want to give it. So we say, hey, call this first image latest, for example, and to build the current directory. So with the dot, we say to build the content of this directory. And Docker is smart enough to look at this directory, find the Docker file, and execute the instructions from that Docker file with this. So you see it executed very quickly. And it built this image from the base image that we had. So we can even do a Docker images to list the images. And now you see that I have a Docker image with the latest tag that's built. And again, to run this is very easy. So we do the Docker run again, and we'll just say first image run the latest. I don't have to provide any other command because you saw the default command was to run the Python script that we added to it. So I just do this. And you can see that this printed the content of our data file. So this was very easy way to, or very simple example to show you how you build these Docker images. The next step is usually to put this image into Docker Hub. And you can do that by a Docker push command. I'm not going to do this now, but that's typically the process. You can actually push your image to the Docker Hub or a registry or your cloud registry, and then you can pull and run that pretty much on any environment, on the cloud and so forth. That's pretty much it for what I wanted to show you guys in this demo. I know we ran a little bit over time. I'm going to stop and see if there's any questions now.
It does not look like we have any questions. So apparently you just explained it so well, Parham.
Appreciate it. Thank you. If you guys have any questions, you can always reach out to us. So I also wanted to invite you guys to go to DataStack.Academy. That's where you're going to find a lot of our upcoming webinars, but you're also going to find information about our data engineering bootcamp. So we run a data engineering bootcamp. We have classes starting actually on March 14th. It's not too late to register for those if you're interested. We still have a few seats open. And with that bootcamp, it's a 20-week long process where we're going to teach you a lot of different data engineering techniques and tools that are used. So Docker is, of course, is one of them, but we use Airflow, we use Spark, we use Python, and a lot of those, again, data engineering topics are covered there. Awesome. Thanks, CJ.
Thanks to you too.
All right, I'm going to stop recording and let's stop the share. Take care, guys.